This is something related to SHM. So we have a capacitor here. This is a spring. Initially at this particular position. So this is the initially equilibrium position. Spring is at natural length for this. Some SHM also can be asked. So let this be a rod. Now this rod is pushed by distance x naught. Let me take this as x naught here. So there's a rod AB as given, no? And I'll take it PQ. Because acceleration will be using symbol. So let me make it PQ. B bar into the plane. So what happened? The spring got compressed, no? In fact, the spring got compressed and I release it. So now there's a mean portion. So there's a natural length of the spring. I'll call L naught. What is L naught? L naught is natural length of the spring. This is very important. L naught is natural length of spring. Initially what happened? The spring is at natural length. That's what x equal to 0 is telling. I compressed it by x naught, I release it. Then we have to discuss the problem. I'll make it a little bit more. It's asking us to calculate the time period of oscillation. Little bit some good observation you have to make it. Don't do for off cycle. In another off cycle, we don't know how the system will behave. When I release it, tell me what will happen. Spring force will act here, no? This is released from rest. Kx naught will act, and as it starts accelerating, then the moving rod will behave like a cell, then EMF will be induced, then the charge will get deposited in the capacitor, then the rod will accelerate, then we have to check it, what is the time period of oscillation. Okay, let's. In exams, I don't think so you can draw so many diagrams. Huh? You have to be. So let this be at a distance x. It has approached near to the equilibrium. Let this be x, that one. This was the initial portion I released it. So now it got accelerated. So B bar into the plane. Check it. Which end will be higher potential? Which end of the rod will be higher potential? Velocity of the rod will be in this direction. Then in what direction the induced current will flow? B bar velocity. So this end will be at higher potential. This will be lower potential. So I can replace with a cell here. Let's have this one. So this will be Q minus Q. So the induced current will flow in this direction. So how BIL force will act on the rod? B bar current. So the BIL force will be acting in this direction. This is some extreme, right extreme. This is a mean position. This will be a mean position. What we have is a right extreme. And what I'm giving is intermediate position. Okay, let's write equation for this. We know there is no resistance here. Look at the entire problem. There's no resistance. There's no resistance in the circuit. So what is the basic equations we can write now? Shall I scroll down? This is t equal to 0. This is at any time t. What are the equations of motion? Kx, the acceleration will be towards right. So ma equal to kx minus bil, no? And we know if a capacitor is there, what is q? Q equal to ce, or this is equal to cblv, or this should be equal to I is equal to CBLA. So in place of I, I'll write CBLA into L. So bringing onto that side. So this will be M C B square L square into A equal to Kx. Or what is A is equal to K by M C B square L square. And this acceleration is opposite to displacement. So I'll get the time taken, time period. Is it our answer? I think let it pass through the mean portion. At mean portion is the maximum velocity, and the spring what will happen? The elongation of the spring, the diffraction of spring will be zero. Once it crosses mean position, what type of motion is going to discover? The spring force will act towards right, no? Then now the BIL force will be acting, still be acting towards right only. Then it will undergo retardation, comes to left extreme. This is for what is this acceleration from right extreme to mean position. Time taken to move from right extreme to mean is what I can predict here now. So this will be time taken should be equal to 1/4 of the time period. 1/4. This will be 2 pi. Will agree this? This is what time taken to move from right extreme to mean. Right extreme, I'll write symbol M. Once it arrives at mean, it will have maximum velocity, no? Then still what happen? The induced current will flow in same direction. But spring will get elongated, no? What is the state of spring? Compressed. You see, now the problem will change slightly. You have to be very careful here. Let's come for this. I'll keep total diagram. I'll make it visible. Check it now. See it. Now let it arrive at the mean position will be here. This should not be there. No? Yeah. And the spring is compressed. A spring will be elongated now. The spring force inward action will act in the direction, but the induced current should be in same direction. BL will be in same direction, and now it will undergo retardation. Please, I think I can show only this much. You have to really understand these two diagrams. There's a mean position, there's a mean, and somewhere here will be left extreme. Now write equation for motion here. Ma is equal to kx plus bil, no? And what is I? I is again same thing after substituting. This will be CBLA. This is it. So this will become M minus CB square L square A equal to Kx. So what is A equal to in this case? Kx by, look at now. So what about this time period? Time period from mean to left extreme. This is the left extreme. How much it should be? 1/4 of what we calculate here. This will be called T dash. And what is T dash? T dash should be 2 pi m minus c b square L square by k. Are the time period same? No. For one of from right extreme to mean, it will have one time period. From mean to left extreme, it will have another time period. 1/4 of time period is what? This one. So now TML you calculate. So this should be equal to how much now? 1/4 2 pi. Try to see in the numerator. You have plus sign, minus sign. So in EMI chapter, you try to be careful about SHM. That's what one question I just brought it here. What is the total time period of the system? 2 times of this, 2 times of this. Agree, no? So time period T naught. So what is T naught? T naught should be equal to 2 times of TML, 2 times of RM plus 2 times of ML. That one. I'm very sure once students reach here, no, what they do? How okay, the same thing will get repeated for in left off, and they'll put answers same, but options are different here. So whenever in that EMI chapter comes, the SHM you have to be very careful. Conditions of SHM comes, you have to be careful.